Hi, thanks for checking this video out. Google Sheets provides the query function, which provides similar functionality to the SQL select statement. However, the query function does not provide all the functionality the SQL select statement provides in most SQL Server implementations. The purpose of this video is to bridge that gap by simulating the join clause offered by most, if not all, SQL Server implementations using the Denormalize custom function. The join clause is used to combine rows from two or more tables based on a related column between them. SQL databases typically are designed with some degree of normalization. Normalization is the process of organizing data in a database. This includes creating tables and establishing relationships between those tables according to rules designed to maintain data integrity and to make the database easy to maintain by eliminating redundancies. Redundant data wastes space and creates maintenance problems. If data that exists in more than one place must be changed, the data must be changed in exactly the same way in all tables. Otherwise, the database loses integrity. For example, a customer address change is much easier to implement if that data is stored only in the customers table and nowhere else in the database. Data normalization is beyond the scope of this video, but there are many forms of normalization, and oftentimes database designers will denormalize a bit to regain some performance lost by normalizing data to the nth degree. I provided a link in the description for more information about data normalization if you're interested in learning more. Since query does not support the join clause, I wrote the custom function denormalize so we can keep our data in normalized tables, yet flatten them for the purposes of queries. Google uses AppScript under the hood for the Google Docs suite of tools like Sheets, Docs, Forms, etc. AppScript is based on JavaScript. I'm sharing this sheet with the examples we'll be covering. The custom function denormalize will also be in that spreadsheet in the apps script. That link is also in the description below. Please make a copy of this spreadsheet for your own drive so you can make changes. The denormalize custom function script is also beyond the scope of this video, but feel free to study it if you like by selecting the Sheets, Extensions, AppScript, and the script also has many supporting functions in here as well. There are many join types, and the inner join is the most common, but the denormalize function also supports left, right, and full joins. Join types are also beyond the scope of this video, but I provided a link to SQL join types below if you're interested in learning more. This is one of my favorite sites, w3schools.com. They have tutorials for just about everything you could want to work with, and you can try things as well. And this one specifically, though, they have a lovely little picture here which basically describes all the 4 different types visually, which is a big help as well. Buried in Google's custom function documentation is a mention to JSDoc. Google Sheets supports autocomplete for custom functions, much like it does for built-in functions. As you type a function name in a cell, you will see a list of built-in and custom functions that matches what you enter. Custom functions will appear in this list if their script includes the JSDoc @custom function tag, as I did in the included denormalize function. To learn more about JSDoc, please check the link I provided in the description below. This is the main page, and then from here you could jump to various other sections as well. This is the one actually for the parameters. I take that back. The main page is just, I have all the direct links, but the main page is here, and you want to check for sure getting started, and probably the param is the most important ones that we care about in Google Sheets. Where to go? There it is. And this talks about the various ways of documenting your parameters. All right, now there are some autocomplete features missing from Google's implementation of JSDoc, and one that stands out is how the optional arguments are displayed with square brackets. So let's take a look at, say, the query function. And then once we look at additional help, you'll see that the third parameter, headers, has square brackets, which means that's optional. And let's take a quick peek at the Denormalize. If I could spell. There we go. Alrighty, so this one takes 1, 2, 3, 4, 5 parameters. Join type is the optional parameter that has a default value. It does not show the square brackets, but there is a workaround that I'm using, and that's simply just to include the information in the description of the argument itself. So here it says type of join, inner, left, right, or full. It's optional and defaults to inner, and in its case insensitive. I am providing the Denormalize function license following the GNU General Public License, which is a series of widely used free software licenses that guarantee end users the freedom to run, study, share, and modify the software. For more information on GNU licenses, please follow the link in the description below. Okay, so that's all the groundwork set. Let's go ahead and go through some examples. So in this example, I have 3 tables: employees, orders, and order details. Really just the beginning of what a SQL database may have. Typically, SQL databases will have a dozen or more tables that are related. So in this case, as far as we have order details, and this would be item IDs assigned to a specific order, but another table probably would make sense would be to have an item database so that we know what this item 9001 is. And then also in the orders we have a shipper ID, but I'm not showing, for simplicity's sake, a shipper table or tables. So you can get as normalized as you like with this, or as denormalize as well, or normalization, data rules normalization. All right, so let's go ahead and take a look at this tab here, example number 1, using named ranges. All of my examples are going to have the headings and then the formula as text, and then again over here as text. So this one will take the employees table and join it to the orders table using column 1 of employees and column 3 of orders. And let's take a look at column 1 in employees. That's the employee ID. Almost all SQL tables will have some sort of ID field. And then in orders, we have that same field, employee ID, listed here in orders. So that's how we can join those. And I'm referencing employees and orders. Those are named ranges. If you haven't used name ranges before, I highly recommend you take a look at it. It makes the formulas much more readable, number one, but also much more maintainable, so that if ranges change, instead of going hunting down formulas in your spreadsheet, you can just update the range addresses in the name range. You just go to data, name ranges, and you'll see we have 3 here. One for employees, one for order details, and one for orders. If those ranges change, we just edit it here, and it would automatically be reflected in our formula. And here we're using the select where this person's name is Davis, last name is Davis. I think we have Nancy Davis there. And column 8, which comes from the orders database. The way query works, if you haven't used query before, is that if you query data directly in the sheet, you would be referencing columns A, B, C, D, etc. In this case, we're passing Denormalize returns an array, so we're passing query an array reference, and it doesn't know what the columns are. So the way we address them in a query select clause is by col 1, col 2, col 3, etc. So col 8 is going to be, I think, what was it? Let's take a look. I don't even remember anymore. Three, has 3, and then 4, 5, 6, 7, 8. So shipper ID equal to 2. Had to look at that, and we have no heading, so we say false. All right. With all that said, let's go ahead and uncheck, remove that single quote to make this an actual formula. And there's our data. All right. Now, the next example is almost identical to this one. The only difference is it's using standard A1 notation. I just wanted to make sure you know that Denormalize accepts both. Same exact formula, other than instead of the name range, we're referencing directly the sheet, employees, and the range, and orders, sheet, and the range as well. And we should get the same results, so we'll remove that quote. And there you go. All right. Now, you may have applications for the denormalize function that don't also involve the query function. So yeah, you can use it all by itself. So in this case, we're joining employees to orders. And instead of the inner, we're going to do a full join. Full joins are the biggest ones. So we'll get a few more rows of data with this. All right, let's look at another example. This one here is going to be orders joined to details. So instead of employees, we're joining the orders to the details. We're using the order ID column 1, and order details, if we look at it, column 2 is going to be the same as the order ID. In this case, we're just going to select all. No filter for name or anything like that, or order number. But you, of course, you could choose to, if you wanted to, put one. All right. We don't have a very big database of order details, but that's pretty much the entire data set. And then this next example shows that you can nest denormalize. You can see here we have it in twice. So the first parameter for the query is denormalizing, or joining, I should say, the employees to the result of joining orders to details. So it could get, you could nest these things, I think, as much as you want, but I'm going to go out on a limb here and say that you were going to suffer some major degradation if you nest too many of these denormalized functions. But this should work. Let's go ahead and make this a formula. And there goes that one. And one more example. And this one's going to just, first one showed how we use the second argument when nested. And this one is simply just going to show that the first argument is the nested one. So we're joining the employees to the orders, and the result of that to the orders detail. And there it is. Alrighty, so that's a wrap. Just a few examples to kind of give you an idea what you can use this for. Thank you for watching. I hope you learned something today. Please feel free to comment, ask questions below.